Anyway, welcome. My name is Andreas Öhlund. I'm a Swede, not a Swiss, so I'm not going to throw shit. I did bring some meatballs with me, but the US Customs kept them, so they're having a meatball party now at Chicago Airport. Just kidding. So I'm going to talk about the transport, i.e. the queuing systems that we run on top of. This could probably be the most boring talk in the world. You know, a lot of tables, you know, message size, limits, and yada yada. So I'm going to try to do it a little bit differently. I'm going to tell you a little bit of a story about a Swedish company. I'm going to try to highlight some of the highlights of each transport and some of the low lights, so that at least when you walk out of this talk, you will have a general picture of, you know, where would I use each given transport. Anyway, let's talk about the Swedish company that I've been interviewing. It's called Swedish Meatballs Inc. Essentially, they are the one that they have the license to produce the trademarked Swedish meatballs, and they have kind of an interesting background. It's all started back in 1926. It was a furniture store was founded in Sweden, and it got bigger and bigger. But they had some issues because a lot of the people attending the stores had some energy problems, and they were feeling depressed, especially the males. So after halfway through the furniture store, they kind of lost their energy. So they kind of thought that we need something to make these people endure a trip to the store so they can actually pay at the end. So they figured, you know, let's create a dish that will energize them enough to enjoy the ride. I know probably many of you have been to those stores. So I can see there's one across the road here even. Anyway, so the tagline for this company is helping people survive at furniture stores since 1926. All was good, of course, but as we all know, those stores were getting much more successful, and as everyone else, they were this meatball firm were sort of becoming the victim of their own success. So they were starting having issues with the system, availability issues, scalability issues. And they kind of realized that they needed to do something with their architecture, and they didn't really know what. So since hygiene is very important in this business, they kind of thought that, you know, a lot of soap would work. So they put soap web services everywhere. But that soap didn't really lead to clean code or clean design or clean architecture. It sort of led them to some kind of web services hell. So back to the drawing board. But one day, the chief architect was in one of those stores, and there was an outage, and you can see the queue was just increasing. And then it dawned on me, right, queuing, could that be it? It's a little bit ironical because Swedes are probably the best people in the world to queue. We know how to, you know, you stand last, you wait for your turn, and if someone cuts the line, you get really pissed off, but you don't say anything. Right? You go home and you're pissed off. Anyway, they thought, you know, let's try queuing, and after debating what queuing system to use, they kind of figured out, since we're a .NET shop, let's, you know, NSMQ, it's there, it's out of the box, just enable it. So as I've been interviewing them, I asked them to, you know, tell me what's the biggest benefit that you saw with NSMQ, and the first thing that they talked about was the store and forward. So even you can achieve this on pretty much all the queuing systems, but NSMQ is different in that sense that store and forward is really the default mode of operation, right? It runs on all your machines. So a quick primer on what store and forward is. It's essentially when you want to send out a message from your process, it gets stored locally. That's why it's called store and forward. So if you want to talk to another node, if that node is up, the queuing system will, you know, sometime later move that message over to the store on the other side. That's the forwarding part. And if your process happened to be alive at that stage, the queuing system is going to deliver it for you. So very simple. That's essentially store and forward. And what's the benefit there? Well, what it gives you is that you don't have any single point of failures, right? You don't rely on a process on some other machine to be up for you to be able to get your messages out. And for them, that was really important because they had a lot of shaky old systems that were down all the time. But introducing queuing like this, they could keep on accepting new orders even though their flaky backends were being rebooted or even redeployed. The next thing they brought up is a little bit surprising. They told me that distributed transactions were really good, which is weird because we all know they're super bad, right? If you Google it, the first 6 hits are going to be some horror story about how bad they are. So I guess lesson learned there, if you don't Google anything, right? If you have a rash on your hand, if you Google it, it's going to be, you're going to read all the horror stories about it. So I sort of dig deeper then, ask them, okay, so even though everyone thinks they're so bad, how come you kind of think it's good? So let's dig into what a distributed transaction really is. So this is from Wikipedia. It's a wall of text, so I'll make it easy for you. So essentially, a DC transaction is about 2 or more network hosts being involved. They're doing some kind of local transaction with ACID semantics, essentially meaning locking stuff in your database. And at the end, they have to agree on an all or nothing outcome. So all those hosts have to say, I'm good to go. Are you good? Okay, let's go. So let's commit. You can kind of sense that this is bad now, right? So what is the bad here? So the bad thing is that, as you're enlisting more and more resource managers, it's gonna get slower, it's gonna get slower, it's gonna get slower. Because remember the all or nothing outcomes, right? That means that all those guys have to agree on something, right? So they have to talk a lot. So there's a lot of overhead. The more resource managers you add, the slower it's gonna get. And also if one of them has some latency issue, remember all or nothing, they have to wait for this one to decide if they're gonna commit or not. Adding ACID to all this means that you're gonna keep locks on your database for long periods of time. And the duration of the entire transaction is the max of each individual one, plus whatever overhead you give. And this creates a vicious circle here, right? Keeping locks for a long time in a database means that you're more open for deadlocks. If you get a deadlock, you'll roll back, and all the other ones have to roll back. So keeping locks for a long time, a lot of rollbacks, you can clearly see that this isn't good, right? So I kind of dig deeper and say, okay, but why is this, okay, this seems wrong, right? You say it's good, but it's bad. Well, it turns out that the reality when you're using NServiceBus, it's still, it's still true everything I said so far, but it's a little bit different, right? So first of all, what nodes do you have around, right? Remember 2 or more network hosts? Well, we have our app node running DTC. NSMQ is a local queuing system, if you remember, store and forward. And we have our client here, your message channel, right? And the other side that we're gonna sync up with is not some random dude's Raspberry Pi over the internet. It's actually your SQL server, right? So in terms of latency, pretty much guaranteed that that's gonna be, kind of low latency operations. So first of all, we only have 2 involved resource managers, right? We don't have many, right? So we have 2 that need to agree, right? So there's much less overhead, right? And what about the duration of the transaction here, right? It's not really random. It's essentially you are executing your SQL that you can craft. Yes, if you use an entity framework or an Hibernate, it could be argued how much you are in control, but it's SQL statements that you execute against your SQL server, against tables that you optimize, right? If that takes a long time, you should be able to handle that, right? So the duration is pretty short here, right? So you have 2 nodes that have to agree. So in this setting, yes, there is some overhead. You will lose some performance, but you'll be surprised on how little performance you will actually lose. So this is what they meant when they said that for them, in this setting, DC was pretty acceptable for them, because it really helped them write very simple code focused on the business problem. So essentially, in this case, when they're creating the meatballs, they call their DB, store the meatball in the database, and publish an event telling the world that the meatball is ready. This is really it, right? They don't have to worry about weird things like idempotency, you can't even spell that, and ghost messages. We'll talk later about sort of what you have to think about when you're giving up on DTC. Yeah, that's it. Well, you might ask, what about non-transactional things, right? We saw this on the Saga masterclass a few days ago that, the answer to everything in life is 42, but in NServiceBus, the answer to everything is send a message. So if you want to do something that cannot enlist, or if you want to have 2 resource managers involved, instead of doing it on the same pipeline, you send a message, right? Instead of making a call to web service to charge a credit card, instead, send a message, right? Because now we're down to 2 resource managers again, right? The database and the queuing system. And then we'll create another endpoint that will handle the credit card, short credit card command. So that will be the queuing system and a non-transactional resource. So, if you don't know, that's the way to solve things within NServiceBus. Send a message. Yeah, I mean, everyone that's set up the DTC knows that it's kind of finicky. You have to muck around with a lot of stuff. You have to talk a lot with your ops people. But to be honest, once you get it working, it works. It's rock solid, right? Most of our clients are on NSMQ and SQL Server combo, and we rarely hear complaints in this area. So just learn to use DTC pinging XE, and you'll be good. Of course, there is something that you need to think about, and it's all about trade-offs. Because if you're leaning on the DTC to write less code, you're essentially making a trade-off of shorter time to market, quicker getting your code into production with less bugs, versus taking locking yourself into a specific setup. But if you're fine with running on Windows using NSMQ, talking to SQL Server or Oracle, that might be perfectly fine. But you have to be aware that if you want to switch to other queuing systems or other storages, you can't do that without recoding. And we'll see later when I talk about RabbitMQ what kind of code change you will have to do if you want to get away, stop using distributed transactions. And of course, it comes up quite often that NSMQ is dead. Well, Mark Twain even quoted NSMQ, right? So it's still there. I think it's going to be around for quite some time more. So you still have plenty of time to migrate if you want. Was it the other way around? Was it Mark Twain? I don't know. I can't remember. Anyway, continue talking to them. Turns out they have the same problem as everyone else. The big ball of mud. They call it the big ball of meat. I guess that's the nature of their business. They wanted to essentially break up their monoliths, applying the UDI, the Han, ADST principles, componentize, loose coupling, and all that. And it was fairly hard. They had this huge SQL Server app, store procedures, left, right, center. The consultant who wrote all that, they actually lost the. They almost didn't have the code. Of course, they've been kind of burned on that SOAP web services architecture, and they were kind of looking at a meatball-oriented architecture, but yeah, they were not sure. But now the latest type, the micro-meatball architectures, they were really trying to, they're hoping that this is it. So the challenge they had, how could they start to break up this SQL Server monolith? So they kind of figured that if we can start getting events out of our database, that's a nice first step to start publishing events out, and then we can cut up this big ball of meat and replace it one part at a time. So they were looking at different ways of getting those events from the database out into NSMQ, and it turns out it wasn't that really easy. So they kind of thought that there is this SQL transport. And no one has been ever chosen SQL. We all know that. So, kind of figure, if we use a SQL transport, we could actually write logic in our store procedures and, God forbid, the triggers. So, achievement unlocked, having trigger code in a slide. This is first for me. There is a place for everything, and I think triggers is pretty nice here. It's a very, you don't have to wade through all that store procedure logic or whatever code you have. In this case, if there is an order inserted in the order legacy table, we will publish an event called order accepted, and the SQL transport will pick it up. So that's one of the key benefits of the SQL transport, is that it's very easy to integrate and get events, get messages out of your old SQL systems. Of course, now they had two transports. They had NSMQ and they had SQL. So of course, after a while, I realized, we need to get those ones to talk to each other. And we don't have an officially supported bridge yet, but we are slowly sort of building up the building blocks to provide that for you. It's a really hard problem to have a generic bridge that just works. But in V5, we added the multi-hosting feature, so you can have two endpoints in the same process. And as Udi mentioned in his keynote, we're adding multi-serialization in V6. So taking small steps towards a bridge solution. So now that means that you can use different serialization formats in the different parts. And we have a sample up on our doc site that shows you how to bridge SQL and NSMQ. So the point-to-point communication is fairly easy. It's the pub-sub that's the tricky part to get right, and the consistency. Bridging a non-transactional queuing system with a transactional ones. There are some challenges with duplicates. Well, and I kind of asked them, okay, what's your experience with using SQL as a queuing system? And the word they were using is that it's really comfortable, like the sofas at the store. Well, some of them, I guess. But the key thing they brought up is that they can now start using queuing without introducing new infrastructure. And they were looking back to the time where they were introducing NSMQ, and they said that if we would have known this, we probably would have went with the SQL transport right away, because I've seen that myself, that the bike shedding that will happen when the company is gonna select a queuing system is everyone and their dog has an opinion. My grandma used this queuing system, it's awesome, and then no, that's no good. We have to use X. So using SQL transport could really avoid that type of derailing your project, right? You can get queuing in without having the one new piece of infrastructure discussion. Of course, high availability already in place. If you're depending on SQL Server, you probably already have active passive clusters and whatnot set up. And of course, backups, that probably is already in place. And it's a fairly unique scenario here, because now you can get a consistent snapshot backup that includes your queues and your business data. So this is probably the only transport that can give you that point in time. We take a backup, then we have exactly the messages and the business data in a consistent state. So of course there is downsides as well, and the one they brought up is it's gonna cost you. How many is using SQL? Is it expensive? Well, it can be expensive because when you scale SQL Server, you most likely going to scale up, and that's what Microsoft wants. So you need the enterprise editions and data center, whatever they call it, and prices just keep on going up. And if you want to be super highly available, you turn on SQL Server always on. That's probably the most expensive checkbox in the world. Well, selecting SAP as a business system might be more expensive, but this one is up there at least. One thing to know, when you turn on SQL Server always on, you will lose the DTC. But Microsoft is reintroducing it in 2016, so the next version of SQL will actually support the DTC with SQL Server always on. So they were fairly happy. As I said, so they would like to give the recommendation that if you're a .NET shop using SQL and you don't really know what queuing system you want to go with, probably should start off with SQL Transport, and, to test out sort of how messaging works for you and go from there. Right up this time, there was a sort of defining moment for the meatball company. They got a new CTO in he was really power crazy. His motto was conquering the world one meatball at a time. And now things started to happen. They started to buy companies left, right, center. They bought the Swiss chocolate factory because they wanted to have the chocolate meatballs. They bought a lot of businesses, out of Java business systems. The factory bean provider factory systems. And they had to integrate all that. And given that the new CTO also was a Swede, why not use a queuing system built on Erlang? Because Erlang, right? Built by Ericsson back in the, was it 80s? Can't remember. Erlang is an awesome programming language, and Rabbit is built on it. So they decided, what? We're gonna use RabbitMQ because it's really awesome to integrate things with. That's really where it shines. It has client libraries for every programming language known to man. It runs on all the platforms. It's AMQP compliant. If you want to connect a lot of different platforms, Rabbit is really, really interesting. All that was fine. One thing that sort of was a wake-up call for the development team is that now they lost all the transactions. Rabbit doesn't have any kind of transactions at all. So there's a few problems with that you have to know about and know how to mitigate them. The first one is ghost messages, and the other one is duplicates. So we're going to dig into what I mean with ghost messages first. So remember that simple code we wrote with NSMQ? That's all fine. The problem with when you're losing transactions, now the order of statements matter. If you happen to do the bus.publish first before you store, no transactions mean that is not going to roll back. So if your database throws a deadlock or something, that message is still going to go out. And this might seem sort of, yeah, it's so obvious, right? I mean, of course, you need to put the publish last. But remember, NServiceBus supports multiple handlers for the same message. So in the real world, it's not that easy to spot those ordering problems. You have to do very thorough code reviews to spot those. So in this case, if the DB rolls back, we have a ghost message. And they're really, really tricky to deal with, right? So we haven't stored anything in our database, but we tell the world now that there is something, right? So as we saw in the Saga workshop, a lot of downstream business processes will now kick off and do their thing, but we still haven't actually stored anything, right? That can create some nasty situations where you're billing credit cards, but you're still not shipping orders, you know, nasty stuff like that. Be aware. Next one is to deal with those duplicates, right? Because in this case, you know, we blow up on the store, we send out the message the next time it actually works. So in scenarios like this, you will generate duplicate messages. So you have to write your code that you write will have to be prepared to the dealing with those duplicates. So if you first look at inserts, so essentially what you would need to do here is that, first of all, you need to have client-side generated IDs. That's a good thing anyway, so you should probably be doing that anyway. So you have to have something in the business data that uniquely identify the thing you want to do. So in this case, we have a meatball ID. So in this case, we're inserting a database, and if that thing throws a key constraint exception, we just have to mute that, and we have to call bus.publish anyway, because we don't know if the last time when we actually inserted it, if we were able to publish or not. And this will generate further downstreams that your downstream duplicates that your endpoints have to deal with. So to deal with inserts, you have to try catch the key constraints. The other scenario is when you're doing updates, and this is the tricky one. So please forgive my pseudocode here. So essentially, in this case, we're adding meatballs to a plate and incrementing the count. So in order to figure out if we're dealing with a duplicate or not, we have to remember what message ID hit this instance, this entity. So in this case, we're only updating the meatball count if I haven't already processed this message. So, you know, however you achieve that, but in this case, we're just inserting the message ID in a collection on that entity as we are processing it. And of course, you have to publish always as well. So some non-trivial code that you'll have to write if you want to be 100% consistent. Most people don't do that. They just hope for the best. And sometimes that's OK, right? But you have to be aware of it. Fun enough, this is essentially what we are doing for you. So if you're happy with some infrastructure lock-in again, you can actually turn on the Outbox feature on NServiceBus, because it's sort of doing that infrastructure level message ID deduplication for you. But again, now we're back in lock-in territory a little bit, right? Because we only support for now and Hibernate and Raven. So if you're fine with those databases, instead of writing that code, you can turn on the Outbox instead. But if you want to use MongoDB or something else, then, well, you have to write the persistor yourself or ask us to do it. So when you're switching to a non-transactional queuing system, be aware, you know, that it's most likely you have to go through your source code and make sure you're prepared for the duplicates and those ghost messages. Anyway, from an operational perspective, I talked to them, and one thing that caught them a little bit off guard was the fact that they were kind of used to NSMQ. They kind of felt it a little bit with SQL, that this kind of single point of failure feeling. And well, RabbitMQ is a broker, right? So you connect to the broker, it's running somewhere, and then you send and receive messages from it. So you can set RabbitMQ up in store and forward mode, essentially install Rabbit on all the boxes. Then you install the shovel plugin or the federation plugin, and then Rabbit behaves like NSMQ. But that's nearly not what most people do. Most people go with clustering instead, and quoting the RabbitMQ doco, I'll definitely give them bonus points for honesty, because they don't really handle partitions well. So this is quoted from their doco. So if you have issues with a network, with the cluster partitions, some really bad things are going to happen, and you need to be prepared for that. So to understand where the problem lies, we have to look a little bit on how HA really works in this mode. So if we have a cluster, so we have a load balancer in front of it, we have 3 nodes, A, B, and C. The way it works is that each queue you create, sort of, one of the nodes becomes the master for that queue. And as you add and remove nodes, you know, the responsibility shifts, but at any given point in time, there's always one master for the queue. And by default, it's the queue where you created, it's a node where you created the queue. So essentially, if node C is the master of the queue, all writes and reads is going to happen on that node, and the messages are replicated to other nodes. So if node C goes down, another node will have the data, and it will become the master. This creates some funky behavior when you're scaling out. So if we have a message coming in via the load balancer, so let's assume for now the queue that we're going to stick this message into is on node C. If we're unlucky and the load balancer sends us over to node A, Rabbit is then going to detect that and say, you know what, you have to go to C instead. So you have to pay an extra network hop. And how many have gotten those black books that David created about a fallacy? So we all know that the network bandwidth is not infinite, right? So you're going to pay an extra network hop. And if you have large messages, this is going to start to slow you down. So in this case, there's a 66% chance that we're going to have an extra network hop. So, and the more nodes you add, the more you increase the likelihood of you having to pay an extra network hop. This isn't really, I mean, it's just, you know, HA hurts scalability. It's not a huge deal, but you have to be aware. Where the problem comes is Rabbit can suffer something called a split brain. So if we have the same setup here, again, assuming that the queue we're going to target lives in node C, if for some reason there is a partition in the cluster, so node A from a network perspective is separated from the other ones, then the minority, the node A side of the cluster is going to elect itself as the master, right? Because it doesn't know about the others, right? So in this mode now, node A thinks it's a master over queue, and node C will still believe it's the master. So as new load comes in, we will be writing on both sides of the cluster, which is fine. But the problem is when the cluster heals again, RabbitMQ has an auto heal mode, which is thankfully not on by default. But if you have the auto heal mode on, it's gonna pick the minority, and it's gonna remove all the messages and reapply the ones from the other side. So in that case, all the writes on the node A side is gonna be gone. So in this case, you would have lost 33% of the messages coming in. So the only way to deal with this, there's a lot of famous blog posts on the internet. If you just Google for call me maybe RabbitMQ, you can read all about this. So the key thing here is that do not use auto heal, because otherwise you're going to throw away the messages. So when this happens, you need to detect this. You need to pull all the messages out of node A and reinsert them into one of the other nodes manually. I've seen some blog posts claiming that they have sort of the step-by-step guide, but I've never really seen anyone pull it off. So just be aware that if you don't want to lose messages, you have to be really, really careful to set this up correctly. So essentially, you know, if you're going for a highly available Rabbit cluster, really make sure you involve the professionals. Pivotal, the company behind Rabbit, and their partners, to really make sure they set it up properly. Anyway, all was good. You know, they lost some data, but you know, that was fine. But the CTO wasn't done, right? Conquer the world was his motto, right? So they want to get in the fast food business. So they decided to open a chain of restaurants across the world serving meatballs. And they started to look, you know, what kind of, you know, how can we build this infrastructure? And of course, being a .NET company, they started to look at the cloud platforms, and, you know, being a Microsoft shop, looking at the Azure cloud was the reasonable move for them. So we support 2 queuing systems there. So you know, it's Azure ServiceBus, which is the advanced one, but there's also Azure Storage Queue. So the team over at the Meatball company was sort of debating which one should we use: storage queues, ServiceBus, storage queues. Well, storage queues, that's the dirt simple one. It's just a queue, right? You push messages into the queue, you receive messages off the queue. It's very stable from an API perspective. It's quite performant. Essentially, that's actually a queuing system that is the base service for a lot of the other Azure services. So when other Azure services need to shuttle data around, they actually run that on top of the storage queues. But it doesn't really have any bells and whistles. And in this case, they selected Azure Service Bus because it has a lot of advanced features for integration. It supports relaying, it's AMQP 1.0 compliant, it integrates with event hubs, it has a lot of interesting stuff. So the team said, you know what, we'll use Azure Service Bus. It doesn't really matter, this was a big shift for them. It doesn't really matter what queuing system they would have chosen here, because this is sort of the first move from them running their own infrastructure over to platform as a service, which essentially means that your infra is run by someone else, which is usually a good thing because, I mean, Microsoft, they have a lot of time and resources they can put towards running your queuing system reliably. I guess the timing is fairly nice because last week we had a major outage in the EU West zone where a lot of the Azure stuff was down, and I think there is a current outage right now, right? Yeah, the AD is off for whole of Europe or something. They might be fixed now, but of course, when things happens, you are not in control anymore. Most of the time it's fine, but just be aware that when you are not in charge of the infra anymore, they can patch it and they can change it underneath you. So you have to be prepared for this. Another thing they brought up as an interesting benefit is well, back in the old days, shitty code was just shitty code. But when you're running like this, shitty code becomes expensive code because you pay by the number of storage transactions you do. So it might sound bad, but essentially that credit card bill really pushed them to clean up their code and really reevaluate, should we really be doing it like this? So, if I remember correctly, they use the term credit card driven development. So, or cost driven architecture, whatever you want to call it. Yeah, so that's an interesting angle. Well, they selected it because, well, they're going to have stores all over the world, right? And, well, running on the cloud, global operations just works, right? Well, as long as you think about a few things. So, yeah, how do I partition stuff? What about legal? There are different rules about data privacy in different areas of the world. Or what about security? And what about latency? And the last one is the one that kind of caught them off guard a little bit because, well, they had stores all over the world, and by using Azure, they thought that, well, you can just treat all parts of the world equally, but that's not really true, right? So we talked about the network is reliable fallacy. We sort of talked about the bandwidth is infinite, and here's another one that's still true. So Peter Deutsch was pretty right back then when he coined the fallacies. So this really hit them, right? Because, well, I'm fortunate for me, I'm working with a lot of Australians, so I get reminded daily about this. So they actually sent over a picture of the Australian internet infrastructure. Latency, Microsoft doesn't really have any other network equipment. If you're going to shuttle data between Australia and Europe or Europe and the United States, you will pay the latency costs, right? It's orders of magnitude higher compared to calling stuff that's close in the same data center or in the next availability zone. So there's a reason why Microsoft doesn't have really any replication services or anything that works across different continents. The only thing you'll get is replicating within availability zones that are close to each other. So when you go into the cloud, make sure that you really take latency into account. And there is no rocket science here. Somebody taking this course, how do I handle latency? Make sure that you're not chatty. Try to be as coarse-grained as possible. Bring as much data as possible. Craft APIs that doesn't rely on a lot of back and forth. Try to batch things if possible. And batching, that's a thing that we've been looking at, and that's something that we're going to introduce, that we have now introduced in V6. We have something now called batch dispatch, We kind of built it sort of mostly for Azure, but it turns out that it's fairly useful for all the transport. It's going to walk you through what it means. So what we do essentially in V6 is that as your handler executes and you're doing your bus.sends or bus.publishes, we actually, kind of like how the compiler can rearrange statements when it compiles, we kind of hold on to those messages. We're actually not going to dispatch them right away to the transport. We're just going to store them for you for a little while so that after your handler is done, we'll collect all those operations and we'll hand them off to our transport adapters at the end so that our transport adapters for Azure Storage Queues, Azure Service Bus, RabbitMQ can, if possible, do smart things, knowing that here's all the messages that we're going to send. So in the Azure case, we can essentially, well, first of all, we're using the async API, and as Daniel showed you, we can now have all the 3 operations going on at the same time. But we can do even more here because Azure Service Bus actually supports you to batch things up. So it has a message limit of 256 kilobytes. So if all those 3 messages are less than 256, we can actually pack those 3 together into a single call. So we can actually reduce the number of calls as well. And we've seen early test shows that we can get latency down from 100, 200 milliseconds down to 10, 20 milliseconds for the same type of operations. So if you're sending a lot of small messages, this is really going to make a difference for you. And the interesting part is this kind of optimization is only available in the async API, in the async SDK for Azure Service Bus. So Microsoft is only optimizing the async API, another sort of way of pushing users over to using async instead. So in version 5, where we're still calling the synchronous API, we cannot do any of this. So a little bit sneaky. A nice side effect of this is that we actually no longer need to worry about the ghost messages. Remember how you have to be careful with the order of statements? But now in V6, since we're holding on to everything, we guarantee you that we're not going to be talking to the queuing system unless everything in the handlers actually succeeded. So you no longer need to worry about the ghost messages. We still have options for you to request an immediate dispatch. For some scenarios, it could be valuable for you to say, don't return back to me until you're 100% sure that the queuing system has accepted this. So there's a new API for that. You can look that up on our docs site. If you want to say, please send service bus, no batching, no nothing, send it straight out and let me know when it's safely stored in the queuing system. But as I said, it's really interesting for the other ones as well. For RabbitMQ, we're using something called publisher confirms to make sure that the queuing system has act and store all the messages on disk. So now we can do that in batch. You can say, here's 3 messages. Let me know when all 3 of them are done. So we can optimize a lot of the other transport as well. For the SQL transport, we can batch statements together in one go against the database and so on. So it has some really nice side effects. Yeah, so essentially that was the journey they took from introducing NSMQ, using SQL to get stuff out of the database, bridging it, integration with RabbitMQ, going to the cloud, using the Azure transports. And I think that summarizes really how you need to go about the transport, right? If you compare performance, they all perform pretty similarly. They all have roughly similar message size limits. That's really not what you need to look for. You need to see, this transport, does it fit the current situation I'm in? And does it fit where I want to go in the future? And how much environment locking can I take now? And how much work is going to be to transition away? So I used to be a consultant in the past. So this is always what if someone asks you, you always say it depends. So it really depends. Do the research, talk to us, talk to others. And remember, you can use more than one, right? So I don't know if there's a term polyglot transport, but if there is one and it hasn't been claimed, I'm claiming it now. So polyglot persistence is cool, and polyglot transport is even cooler. So yeah, thanks. If you have any questions around transports, I'm going to be here today and tomorrow. Just, walk up to me and we'll have a discussion about transports and see how what will fit for your situation.